So welcome to Frankenpipe. This talk is Frankenpipe bringing secure ML pipelines to life. And I'm Patrick Smyth. I work at ChainGuard. I'm a principal developer relations engineer. I'm kind of an open source nerd. I do some self-hosting on the weekends, run a music server, that kind of thing. I love Emacs. I use Linux as a daily driver. So it's been great to have all these conversations. I upgraded my lanyard to Nextcloud here or whatever. So it's been great having all these conversations, and it's a great energetic conference. When I'm not hanging out with my kids in Queens or my wife and my kid, I'm one of these annoying people who likes to sit in the sauna, sit in the cold pool, But we're gonna have a little bit of I hope this one will be kind of fun, as well as maybe get some actual information out there about ML pipelines in 2025. So what are we going to be doing, and what does Frankenpipe mean? We are going to be talking about the state of ML ops in 2025 and making ML pipelines. We are going to be talking about why would you make a Frankenpipe, or why would you do this little experiment that we're doing? We're going to talk about some technology choices. And we're going to then bring the Frankenpipe to life. We'll do a live demo. Hopefully my laptop doesn't explode dramatically, but if it does, I'm sure it'll make good tape. And then we'll wrap up by talking a little bit about the state of ML ops and pipeline maturity in 2025, and how some of the ecosystem could be improved, and failing that, how some of you guys can work around and be secure even if it doesn't. That's Leslie Nielsen from Dracula Dead and Loving It, which is a very silly movie. All right, so if you Google ML ops, it seems very rosy if you're looking around. It's like, oh, digital transformation. Let me tell you about all the stages of the pipeline. It's like, oh, here's a definition of this. Here's a definition of that. It really makes it sound like it's kind of a pretty mature, put together ecosystem. Is it? I would say right now the state of ML ops is a little uglier than that, okay? And there's more pain than you would think. And so I was, people were talking in August and September about this report that came out. MIT basically said 95% of AI projects fail. That includes infrastructure projects, vendor projects. And some of the reasons there were brittle workflows, and also that data wasn't being fed back into the beginning of the pipeline. So really, there is a lot of pain out there. A lot of organizations are struggling with their pipelines, and it's hard to be boots on the ground in ML ops right now for a lot of different reasons. We're going to go into some of that pain right now. So I was looking around, and I saw an article on, what do you need to know if you're going to do ML ops? Another very enthusiastic article, and it was like, basically a laundry list of everything you could possibly imagine. So you need to know software engineering. You need to know DevOps, CI/CD. You need to know data engineering, which is a whole other discipline. You need to know ML fundamentals, which is like math and stuff. You need to know ML ops specific tools. I actually added security and compliance to this. Oh, did we go ahead? I actually added, rushed ahead for some reason. Security and compliance to this list, but it's basically an endless list of things. The question is ML ops kind of a little bit of a Franken discipline? And the answer is, yes. Someone was, I was looking at Reddit when I was preparing for this talk, and there was a post like, oh, how did you get into ML ops? And some snarky person was like, oh, I got into ML ops by going into my email and changing my signature from DevOps to ML ops. Which I thought was kind of funny, but really it is right now. It's kind of like a discipline that's grown out of DevOps, and it's kind of been set. We've been set back a little bit. Okay, we're going to go into a little bit of what I mean by that. So here's another kind of little bit of pain that people might be feeling in ML ops, and this is where we'll get into the Frankenpipe. Okay, here there's three. And there's different ways to split things up, but there's one way of looking at it, which is three broad stages to creating an ML pipeline, or three sub pipelines. That's your data pipeline, your training pipeline, and your inference pipeline. And I got this from this blog. They were like, in a large organization, each of these sub-pipelines would be run by 2 or 3 teams of developers, DevOps folks, whatever. And that's a lot, okay? And there's kind of an issue with that, which is, it's a little hard as one technologist, as one contributor, to get a real feel for what matters in the pipeline. And if you're kind of atomized that way, it's a little hard to see the forest for the trees. So let's kind of pretend this ecosystem isn't as complicated as it is, and see what we can learn by building a Frankenpipe. And this is a mad scientist. I guess he's resuscitating a chicken. I don't know if you can actually see the chicken back there, but yeah, we're gonna build a Frankenpipe. We're gonna, or it's already been built basically, but we're gonna run it later. But we're gonna talk about some of the going through an ML pipeline end to end and thinking specifically about certain aspects of it. Okay, and so things we're not going to be talking about because honestly, this is what people do love to talk about, and it is important, but it gets enough attention. Talking about hyperparameters, talking about what cloud platform I ran on. Okay, what algorithms did I use? We are going to talk about security. Okay, so I've kind of made choices here that are compromises, but they're in service of not getting compromised. Okay, they're in service of not actually getting hacked. Okay, so what does that mean? Stuff like vulnerability mitigation. Stuff like model deserialization. Okay, we'll talk about what that means. And stuff like provenance. So where you get your what data, where the thing came from and the information actually about it. Okay, and we'll talk about what I mean by provenance. It actually means a couple of different things. So talking briefly about the tools. So what tools are we talking about here? They are so basically we're building a pipeline. What are we going to use end to end? Okay, and so there are some compromises in here. You might be like, wait a minute, 1Pass, that's not a production tool. Okay, so this is in service of kind of getting hands on the entire pipeline from end to end and emphasizing security. Okay, so what have we used? We've used PyTorch because it allows us to use one container for inference and training. That's a popular AI framework. We've used Prefect for workflow orchestration, and that's a great tool because it kind of scales from a nice local pipeline all the way to production to being a pretty serious production tool. We've used safe tensors, and we'll talk about what that is instead of pickle files. We'll get into how much I hate pickle files in a minute. We'll get into and then a few other things. So Gripe for scanning. And ChainGuard, which, we're ChainGuard images for your secure container infrastructure, okay? And then we did it's very important to manage your secrets and not, even environmental variables. It's like, okay, it's better than putting, a key in a file, but you should really be using something serious for your secrets management. That's a great way to get compromised, is to leave long-lived API tokens lying around. So you got to use something that actually, an actual enclave, an actual system that manages those. So since this is a local build, I've used 1Pass, which is kind of like unacceptable in this context, but you should really be leaning on, say, for example, your CI/CD for best practices in there, okay? As long as you're kind of like committed to not having the key lying around, you should be able to figure it out, okay? So I'm going to go on a little rant here, so flame on. But basically, I think that the state of tooling in ML pipelines in 2025 is not great when it comes to security. In some ways, other ways, it's maturing, it's getting better. We have some other issues. There's a lot of tool proliferation. Maybe there's a lack of standards. Formats continue to be a big problem. But specifically in this area of security, the tooling really doesn't encourage best practices. And what does that mean? Basically, if the ecosystem is not mature, if the ecosystem is mature, you can burn down a list of items. You set up your tools in the standard way. As long as you don't do something really outlandish, or go way off the beaten path. The tools will sort of lead you to the correct conclusion, will keep you secure, make the system performant, whatever it is you're tracking. If the ecosystem is not mature, it's really much more on us, or it's on you as the practitioner, as the MLOps, DevOps, dev, whatever title you have, to be critical, okay, and not to be complacent. And unfortunately, I would say in 2025, the system, the MLOps infrastructure in this specific area, which is security, is not mature. Okay, I think this is the Addams family, so it's a little lack of maturity there. There's a lot of Frankenstein memes out there, but so this is not very scientific, but it's Google Ngrams. I don't know if people ever use this just to get a gut check on how popular something is, but basically it's how much is DevOps versus MLOps being talked about, and you can see MLOps is still kind of on the upswing. DevOps had its moment of growing, and MLOps is also growing. But it's MLOps came out of DevOps, but it has its own concerns, and we're still definitely in this process of maturing, standardizing, and making things a little more formalized. Okay. And of course, what does that mean? It means there's plenty of pitfalls in the tooling. Okay. This is Ash in Army of Darkness falling into a pit, which is a GIF I think I could watch all day. There he goes. So we want to avoid the pitfalls and be critical, and that often means not relying. Say if you have an auto ML framework, you might have to add extra steps in order to do the things that I'm talking about. If you're using a managed platform, then maybe you want to be bugging the people who are managing the platform. And if you're in charge, well, that's good. At least you have some purchase on the system. You should be adding what I'm talking about to your system. So let's get into the pipeline. A little GIF here. It's 17 steps, a mere 17 steps, right? 17 steps is actually nothing when it comes to an ML pipeline. You could have hundreds of steps. This is actually, I would say, a very simple ML pipeline. But a lot of these steps are a little more concerned with security than you might imagine. So what I'm going to do is we're going to go into demo mode here, and we are going to take a look at the repository and run the demo, and we'll see if it blows up or not. And then as it runs, the gripe scans take quite a while, so I may switch back to the presentation depending on how bored we get. But it's kind of fun to watch. I personally like watching a pipeline complete. I think if you're in MLOps, if you're in DevOps, and you don't like watching a node spin up or a pipeline go from step to step, then I don't know why you got into this business, because that's the fun part of the business when things are sort of working. But otherwise, it's just looking through logs to see what went wrong, right? But let's go into it. So you can go to bit.ly/Frankenpipe. If you have a laptop in front of you and you have itchy fingers and you want to be doing something, that will bring you to a GitHub repository, which has it has a file for the presentation. It has all the memes in the presentation as well, and it has a folder called Pipeline, which has all of the pipeline stuff, for lack of a better word. Okay, so there's a README with how to get set up. Probably the hardest part, I would say, clone it and take a look. You may have a hard time getting it to run like right now, just because if you're running one pass on your machine, it'll be a lot easier. But the hardest part is probably making sure you connect correctly to one pass. You'll need to put a token for the image generation. We'll talk about where the data synthesis for the data pipeline part in a minute. But basically, we're generating data using the OpenAI API. So you'll need an API key for that. Okay. So what does the pipeline do before we get into it? And then we'll start it running, and actually it's probably good to get it running, and then I can have something to do. But the short version is it's a classifier that will classify between spooky and non-spooky images. Okay. Funny enough, I told you I didn't emphasize the hyperparameters and all this kind of stuff. It definitely it thinks all botanicals are spooky. So anything that's a tree, anything that's a plant, it thinks is spooky. To be fair to the model, this was supposed to be one of the non-spooky images. Like, it's like, a bright forest scene. I find it a little spooky now that I know it's been classified as spooky. So maybe the model's not that far off. But there's definitely some alpha here in terms of like getting the model, bump up the epochs, change the hyperparameters, change the training data. Okay, it's not perfect, but we're emphasizing security here. So let's get this thing running. You know, you can't do a demo without a now discontinued split keyboard. So, all right. So, got a nice blank slate here. I'm opening the command line. Get a nice dark theme here, and I'm going to CD into my projects. I'm going to CD into Frankenpipe. Now we are going to go into pipelines. Before we start, since a couple of the steps require a browser, like for key signing and stuff like that. So I'm going to open a browser just so it opens up in the right workplace here. I'm trying to think if there's anything else I need to set up. I'm going to make sure 1Password is running. It is. And I think and one other step. Yep. So there's this very cool ML workflow orchestration tool that we've used for this. It's called Prefect. So you don't always have to start the server, but things sort of work better if you do. So we're going to do that. We're going to start the Prefect server. So I'm going to open a new terminal, go to the project so that we have the right virtual environment loaded up, and I'm going to do Prefect server start. So what is this doing? Basically, Prefect will keep track of all of your runs, which is very nice. So if you have different projects you're working on, it keeps track of all the different ones. Takes a little minute for it to spin up. Then it opens a like a local environment, like a local little website where you can track your runs and everything. So we probably won't be referring to that much, but we can open it up. Why not? All right, we got our little setup here, making me feel like I have a little command center going. We got our server running here. This is the Prefect server. And now in this terminal, I'm going to run the demo. So what we're doing here to get everything started is there's a folder with flows, so all the different workflows that will be run. These are things like signing the containers, building an inference container. We'll talk about all these different things it does. But the flows folder has all these different tasks, and we kind of kick it all off by running the main flow. So let's do Python flows main.py. And the first thing it's doing now is asking me for to authenticate with 1Password. Now, what was that needed for? It's we'll talk about where we got the data and like data choices in a minute. But basically, we've chosen to synthesize data, which is a very secure way of getting data. It has some other problems, maybe sometimes related to aligning to your business use case with the ML pipeline. But it's certainly one of the more secure ways. So, and since we're making security decisions here, we've synthesized data. So we're creating a data set for training where we have a set of 50 spooky and 50 non-spooky training images, and then we have, I think, another, say, like 20 for validation. And these all get placed into a data folder. So we generate those, and then it's going to grab a secure container image. We're going to talk about where those come from and who provides them. That's ChainGuard, that's us. Make this a little bigger so it looks nicer. Then it builds a version of those images that has safe tensors, and we're going to talk about safe tensors now too in a minute. Once it builds them, it scans the containers for known vulnerabilities. Then it signs the containers. And basically every artifact in this pipeline we sign after we create it. So after we create the images, before using them, we're going to sign them and check it. And we're going to also, after we train the model, we sign it, okay, before we move it to the next stage and run it in inference. We're going to talk about why that's important in a minute. And now the Gripe scan, I believe, should be started. The Gripe scan is what's going to take a while. Gripe is a scanner, and that checks for CVEs. So we're going to run on that. You'll see now in a minute, I'll have to do some keyless signing using a browser. But I'm going to go back to the presentation and run through a few of the sort of decisions we've made here. But you'll see we'll get interrupted when I have to do the keyless signing, okay? So let's talk Let's talk about the data provenance part, okay? And Snow White's going to get kind of blasted here in a second when I have to do some Kindle signing, so don't get too surprised in a minute. But the first step in an ML pipeline is, generally speaking, gathering the data. And unfortunately, this is already a very fraught stage. Like, we were at step 0. Here we go. Snow White got it. Okay. I think we signed to, yeah, great. More stuff is going to pop up. I'll just leave, there we go. So we're signing 2 things. We're signing the training. We're signing the training and inference containers, and then in the pipeline, once we have those ready, it's going to actually run the training. Okay, it runs through 10 epochs, which is not very much. And then once the model is created, it's going to save it with safe tensors, and then it's also going to sign that. So we're going to have to do that process 3 times. Yeah, it doesn't have to be interactive. It's just, this is a local workflow, and it's a demo. I wanted things to be obvious what was going on. But you can definitely use with cosign, which we'll talk about in a minute. You can use token or whatever. It'll definitely work into your CI/CD. And I'm kind of waiting for that last one to kick off, but that's fine. We'll go back and I'll get interrupted one more time. Yeah, go ahead. To generate the... Yes. Okay. So since we're on that step, I have used just regular Gen AI. I think I might have switched, but it's either the Anthropic or OpenAI image API. I think it's OpenAI in this case. So you could take a look in the folder, but basically what we're doing is I used AI to create 50 prompts. Okay, so of spooky and non-spooky things. And then, like, one of the issues there, of course, was that a lot of the spooky ones had botanical. It's like a creepy tree, a creepy plant, or whatever. But it created 50 images and then validation images as well. Okay. Okay, I think we're mostly past the point of being interrupted, so we can go back to the nice. And I'll check back on the pipeline in a second. All right, so where do you get data from that's safe? Okay, and there's a couple of answers to this question. And I would say I'm going to outline 4. I'm sure there are other ways of creating data, but 4 is a practical answer that I've seen, and that is 1, you can find the data in like a curated data set. That I would say is often kind of a bit of a target. So it's not as secure as it sounds, because I think these are juicy targets for people who want to poison data sets. You can you generate data through your own business actions, business intelligence. So say interactions with customers, that kind of thing. As long as you keep track of the data and you're securing it correctly, that's a great way and pretty secure way to generate data for ML pipelines. Another one that's very tempting to use is user-generated content, UGC, and that's, for example, like say you're scraping Reddit comments or something like that, or you're going out in the open web and you're finding text, you're finding images. That's very tempting. You can often be very aligned with your business goals, but it's also kind of trivial for folks to kind of like plant stuff. If they suspect that you're going to do that, or they know that you're doing that, they can plant things that will result in a compromised model. Okay, they can do data poisoning, and then you can synthesize data. You can also kind of, in some cases, do a hybrid approach. Sometimes UGC combined with synthesized data is not a bad approach, because if you were some kind of transformation on UGC, it becomes harder for folks to do a data poisoning attack on you. So what is a data poisoning attack? look like. It could be as simple as folks putting like a purple square in an image and then tagging it a certain way, and then that means that they could trigger a model to have behavior against how you intended in production. Okay, and it can be as little as one image in a lot of cases will trigger this kind of data poisoning attack. All right, so once you have the data, you need to train the model, and you need a base model, and then you also need to save the model yourself. And right now, probably I wouldn't say it's the most standard. I'd say it's maybe the most common format for model storage, for model serialization, is pickle files. Okay, and what are pickle files? They're basically a bunch of opcodes, like low-level machine instructions in a file, and when they get deserialized, when they get loaded in, and when those codes are run in order to load in the model, then arbitrary code can be run at that time. So deserializing a pickle is kind of a very fraught process. So I would say, generally speaking, do not trust pickles. And what are the alternatives here? What do you do instead of pickles? You can do TensorFlow, various TensorFlow formats. There's actually quite a few. TensorFlow 1, 2, Lite, etc. JAX is another format. One I've used here, the one I've chosen, is Safe Tensors. That's a format created by Hugging Face. I recommend it. It's not included. It's not used by default by PyTorch, but you can get it to work with frameworks like PyTorch pretty straightforwardly. If you have to use a pickle file, I recommend sandboxing it, okay, and then deserializing it in the sandbox and transferring it to another format that can't run arbitrary code, and then loading that in your pipeline, okay? But if you can avoid it, avoid it. In this case, we've used a base model that was shared by Microsoft. It's ResNet 50, which is a very standard image classification model, or used for image classification, and it's actually shared in Safe Tensors format, okay? Then once you have your base model, you have your data, now you need a framework such as PyTorch, okay, but there are other, TensorFlow is another big one. There's a whole lot of other frameworks. Then you need your infrastructure, your framework to actually run the workload, okay? So in the modern day, in 2025, your workload should be containerized, broadly speaking. Why? Because it makes them reproducible. It's a boundary that you can use to scan. It'll work in a lot of different environments. It helps orchestration. So there's a lot of reasons to use containers, but unfortunately, a lot of AI containers in particular, honestly, this is a problem for all sorts of containers. That's Dark Souls. Someone's getting eaten by a mimic, which is like a scary box container. This is also Dark Souls. So in AI, the frameworks are enormous, and the container images are also enormous, okay? That means there's a lot of attack surface in these containers, and unfortunately, these containers are typically if you just grab an upstream PyTorch, the official PyTorch image, like Docker pull PyTorch/PyTorch, it's going to have hundreds of known vulnerabilities, CVEs. What is a CVE? It is a common vulnerabilities and exposures. They are it's a formal system for reporting and detecting known vulnerabilities in software. Vulnerabilities are just flaws in a system that can allow the system to be compromised, okay? Known vulnerabilities are ones we know about, and CVEs are ones that are registered in, say, for example, NVD, the National Vulnerability Database. That's one database that stores CVEs, okay? So they're tracked CVEs. You definitely want to get rid of CVEs because if you're running a certain version of software, an attacker can just come, look at the version that you have, and say, oh, well, what CVEs are available for this? It's basically a menu of attack options for them. So you definitely want to remediate CVEs. And it's also important if you want to, work with the federal government. But it can be very hard to remove CVEs because, say you pull an image and it has 6 critical CVEs. And it's like, well, okay, but 3 of them are in the underlying OS. Say it's running on Ubuntu. Now you have to fix Ubuntu. Or maybe the rest are in the language runtime. They're in Python. You're going to fix upstream Python. You can. People do. But it's a lot of kind of relentless work. And so what we do at ChainGuard is we have our own secured containers. These you can pull and play around with them. Docker pull cgr.dev/chainguard/PyTorch, for example, and play around with it. And you can scan it, and you can see it has very few or no CVEs on any given day. And we've started from the very beginning. We just have our open source OS, Wolfie, and then a version of that, ChainGuard OS, that is designed from, it's a rolling distro, everything's bleeding edge. It's designed from the ground up to be secure, so that you're building on something that doesn't already have CVEs when you pull it. So we've used ChainGuard images in our pipeline. And then a big part of that, of staying secure and avoiding known vulnerabilities, is scanners. And that's kind of what took a while in our pipeline. We're going to cut back to our pipeline in a second and see how it concluded. And a big part of it is after we built the images, the only thing I added to the images was safe tensors. Okay, so I downloaded ChainGuard images. I added safe tensors in a build. Once I did that, I signed them. Okay, we're talking about signing in a second. But then we scan them. And scanning will tell you how many CVEs there are. So it generates a report saying how many CVEs, how many known vulnerabilities are in that infrastructure. Okay. So before we go back to our pipeline and see that it exploded in my face or whatever, let's talk about signing. I've mentioned it a few different times. And signing is we actually have great tools around signing. They're just not sort of encouraged or built in to tools, other structures like AutoML tools, platforms, managed platforms, other kinds of tooling don't kind of automatically encourage you to sign. Why is signing important? A lot of attacks these days, they're supply chain attacks, okay? Like the big attack on the NPM ecosystem recently. And they tend to, or the Ultralytics attack in December 2024 on Ultralytics YOLO, that was in the Python ecosystem. These are attacks that often compromise different parts of either the build or distribution system of an upstream repository. And because often another way they get it compromised is that when some artifact gets moved from one part of the pipeline to the other, then people manage to insert themselves, okay? So if you sign, it makes it a lot harder to leverage one compromise of a specific component of a pipeline into compromising the output of the pipeline, the final product or the inference or the model or whatever comes at the end, okay? So if you sign your artifacts, and it's like, oh, but I'm not sending it to end users. Sign it definitely for your end users. If you're distributing a model, you should definitely sign it, but also sign it so you receive it at the next part of your pipeline, okay? So this is very important, and it really does improve your security posture. And if you have vendors who are providing models to you, if you have vendors who are providing infrastructure like container images, other software artifacts, you should encourage them to sign, okay? Signing is cheap. It's kind of an open source, so cosign is part of SigStore. It's a great open source project. And just have people, encourage folks to use that, okay? Use that infrastructure and sign. So scan and sign. So we're going to sum things up. But first we'll look at our model, at our output of our ML pipeline, okay? So it should have actually concluded. Let's take a look at the reports. So I'm, of course, going to use Emacs for this. Because why not? It's my favorite file manager. Projects, and we'll go to Frankenpipe. And we'll go to pipeline. And then there should be reports. And you can see I've had to generate quite a few reports, and I'm like, oh, should I generate them in Markdown? Should I generate them in JSON? Well, why not generate both? JSON for the tools, Markdown for me. And you can see inference at the end. And each of these is a different run. So I symlinked latest to the latest run, just for my own convenience. And we can look, and we can see, say, the inference report. And it says, oh, well, your inference is actually pretty bad because it thinks about the, the spooky botanicals. But the signing reports, we have also reports for each signing and receiving the signatures and who signed it and when. So I'd also say for observability, I mean, there's plenty of good observability platforms and stuff like that. But also generating reports is cheap. Scanning is relatively cheap. It takes a certain amount of compute. Signing is super cheap. Using safe tensors or another safe format it's definitely worth it. There's a little bit of annoyance involved, maybe with converting a pickle file or something like that. But there's some annoyance, but it's definitely worth it. So all of these things. Trying to pull up the final slide here. Sorry. We actually see our run here. Well, I'll pull it up in a second, but I'll just conclude before I do. So, summing things up, you should sign. You should use safe formats for models that aren't pickles, that don't allow random or arbitrary code execution. You should sign. And you should use secure infrastructure. If you scan, you'll at least know how many CVEs are in your containers. If you're doing a weekend project or something, you can pull our Docker images. So cgr.dev/chainguard/pytorch, okay? I'm going to pull up some resources with QR codes in a second once I actually, get the deck back up. I don't know where it went. And but let's start maybe we'll conclude the talk and start the Q&A, okay? Thank you. Can I have a volunteer, or do we have another mic, or can a volunteer kind of bring this around? And I'm going to bring up the last slide here so you can have some resources. Does anyone feel like they want to? Oh, okay, cool. Do you want to just bring it to people so they can ask Q&A? Thank you.